Hi, this is Mrs. Doris with Lesson 2-9 on percents. Our objective in this lesson is that you will solve percent problems using proportions, and also that you will be able to solve percent problems using the percent equation. This is important because we can apply it to many real-world problems. All right. Percents are useful because they standardize comparisons to a common base of 100. Percent means per 100. The percent proportion. You can represent A is P percent of B using the percent proportion. All right. The percent proportion looks like this. A over B is equal to P over 100. In this proportion, B is the base, or the whole, and A is the part of base, B. The percent P is always written over a denominator of 100. All right, a little trick that I've learned in using proportions. If you have A is P percent of B, A, the part, goes with the word is. The part we always put on top in our ratio, and the of B goes on the bottom. All right, so is represents the part, okay, in this case A. Of goes with the base, or the whole, in the problem. So if you'll use that little trick, you'll always have your proportions set up correctly. All right, so let's try it with this problem. Finding a percent using the percent proportion. What percent of 90 is 54? All right, well, let's notice what goes together. We have of 90 and is 54. Well, if you can remember, is over of, or part over whole. 54 is the part, and 90 is the whole. Now, sometimes the part might be bigger than the whole when you have a percent over 100. So keep in mind it's not always the smallest number that's on top. All right, then we set that equal to P over 100 for our percent proportion. Cross multiplying, we have 90 times P is equal to 54 times 100. Solving, we have 90P is equal to 5400. Dividing both sides by 90, we get P is equal to 60. All right, so what percent of 90 is 54? 60%. And let's start getting in the habit of writing our answers as a sentence. So we would say 54 is 60% of 90. All right, the percent equation looks like this. A is P percent of B. Now, in this case, the little trick to be learned here is the word is implies the equal sign. P percent will be expressed as a decimal. The word of means multiply and then times b. All right, so let's use that in our next problem. What percent of 84 is 63? And we're going to use it using solve it using the percent equation. So what percent, that will be our P, of means times, 84 is means equals, and then 63. All right, so to solve this problem, what we end up doing to isolate P is to divide by 84. All right, so we have P is equal to 63 divided by 84. And we end up getting 0.75. Now, keep in mind, this is decimal form. So to change it to percent, we move the decimal point to the right 2 places, or you can think of it as multiplying 75 hundredths times 100, which would give us 75%. Writing this in a sentence, we would say 63 is 75% of 84. All right, now let's solve the same thing using the percent proportion. Okay, notice we have is 63, which would go on top. We have of 84, which goes on the bottom. And our percent proportion is P over 100. Cross multiplying, we have 84 times P. Opposite, 63 times 100, I'm going to go ahead and multiply to get 6,300. Dividing both sides by 84, we get P is equal to 75, and that would be percent. Now notice, the only difference between using an equation and using a proportion is when you solve a proportion, you get your exact percentage. When you solve it as an equation, your answer comes out as in decimal form. So you always have to change it in an equation in order to get your percent. All right, problem 3, finding a part. A family sells a car to a dealership for 60% less than what they paid for it. They paid $9,000 for the car. For what price did they sell the car? All right. All right, we're going to begin by drawing a little percent model. And this may help. You don't always have to do this. But you have some options here, and this may help you visualize the problem. All right, so on the bottom, I'm going to show my percents. 0%, 100%, and in the middle, we're going to have, or somewhat, it says 60% less. All right, so 60% less than the whole. This part would represent 60%, which means they're going to sell it for 40% of what they originally paid for it. All right, so they paid $9,000 for the car. 9,000 would be opposite 0. And what we want to know is this part right here, this amount. It's not really the percent. Let's just call it A for the amount, or you could use P for price. So this is a little model that you might use to help you do it. This also kind of helps us visualize the two methods that we have of figuring out the answer to this problem. And I'm going to show both to you. The first method is a two-step process where we're going to find the amount of the discount, which would be the 60% right here, and then subtract it from the sale price. Okay? So, or subtract it from the original amount they paid for the car. All right, so first thing that we're going to do is we're going to find out the 60% of 9,000. All right, so 60% written as a decimal would be 0.60 times the 9,000 is going to be 5,400. And then we take the original price of the car minus that 60% off, and our answer to that question is going to be the amount that they sold the car for. So in other words, $3,600 is what they would receive. Method 2 is finding the percent that they are actually receiving. And this, I think of this as being a one-step process, but it really is a two-step process. The only difference is the first step we're going to do mentally. So in this process, what you think is, okay, 60% less is what they're going to receive for it, so they're actually receiving 40%. So we're doing that part in our heads. Then we take 40% times the 9,000, the original price of the car, and we arrive immediately at our answer of $3,600. All right, number 9, or excuse me, slide 9, I guess it is. Problem 4, finding a base. 30% of what number is 12.5? All right, so we're going to solve it using the percent equation first, and then we're going to solve it using a proportion. And I don't care which method you use in solving, whichever works for you the best. On equations, you can literally write it out one part at a time. Remember, in an equation, we're going to represent 30% as a decimal. All right, so 0.30 of means times what number, let's just call that x, is means equals, and then 12.5. To isolate the x, we want to divide by 0.30. Do the same on the right-hand side. And we get our answer, P equals 12.5 divided by 0.30. And we get an answer of 41, and 0.666 repeating is the same as 2/3, 41 and 2/3. All right, or we could write it 41.6 repeating. So 30% of that is 12.5. All right. Now, let's solve it using a percent proportion. Okay, first of all, let me erase this so that we can see what goes where. 30% can be represented as 30 over 100. That's what 30% means. Of what number is our base? Remember, is over of. Of goes on the bottom. Is 12.5 is our part. So here is our problem. Cross multiplying, we have 30 times x is equal to 100 times 12.5. All right, that gives us 30x is equal to 1,250, and 1,250 divided by 30 is x equals 41.6 repeating, okay, or 41 2/3. All right, let's look at a very simple formula. It's called the simple interest formula. In this formula, the I stands for the interest, the P stands for the principal. The principal would be either the amount of the loan or the amount that you have deposited. All right. R, the rate, is the rate of interest. The rate of interest is always given as a percent, okay, which we have to change to a decimal in our formula. And the T right here is for our time, and that is always in years. Okay, so if it's only part of a year, we would have a fraction or a decimal representing that part of the year. Okay, so problem 5, using the simple interest formula. You deposited $125 in a savings account that earns a simple interest rate of 1 7/75% per year. You earned a total of $8.75 in interest. For how long was your money in the account? All right, well, let's start off with our formula. Interest equals principal times rate times time, and let's fill in the pieces that we know. We know that we earned a total of $8.75 in interest. We know that our deposit, our principal, was $125. We know that our interest rate was 1.75. 1.75 has to be changed to a decimal. So remember on percents, if it's in percent form, I want to go to the opposite direction. So it'd be 0.0175 is our interest rate. And we want to know for how long. So there's the variable that we are going to be hunting for. All right, so let's solve our problem. We have 875 equals, we're going to take 125 times 0.0175, which gives us 2.1875 t. And then we're going to divide by 2.1875 on both sides in order to determine the number of years that we had this on interest. Okay, so 8.75 divided by 2.1875 is 4. So our time is 4, and that will be in years. Okay? All right, at this point, if you feel comfortable, then please work on the assignment for this lesson. It is page 141 and 142, 9 through 37, the odds, and also number 49. If you have any questions, please bring them to class or post them on the discussion board. Thank you. For those of you that would like another example, then stay tuned. And I will show these in 2 different ways. I won't solve them both the same way, but I'll use a percent equation for one and I'll use a proportion for the other. All right, so number one, what percent of 70 is 21? All right, well, let's use an equation for this. What percent, we'll call P, of means times 70 is means equals 21. To solve this, we're going to divide both sides by 70. And so we end up with P equals 21 divided by 70 is 0.3. Remember, we're looking for the percent, so I want to multiply this by 100, which is the same as moving a decimal point to the right 2 places, and that would make it 30%. All right. Number two, we'll use a proportion to solve this one. What percent can be written as P over 100 equals of 50 is our base, is 60 is our part. And then let's cross multiply. 50 times P is 50P. On the other side, we have 100 times 60. All right. Multiplying that out, we have 50P equals 6,000. Dividing both sides by 50, we get P equals 120. So 120, this is our percent. So we would say 60 is 120% of 50. On our one up here, we would, number one, we would say that 21 is 30% of 70. All right, number three, what is 35% of 80? Okay, well, what can be represented by our variable? We'll use x. Is means equals. 35% represented as a decimal would be 0.35. Of means times, and 80. All right, so this is a straightforward multiplication problem. 0.35 times 80 is 28. All right, so to write our sentence, we would say 28 is 35% of 80. Okay, with our answer being the 28. Okay, the next one, let's use a proportion for it. How about? We have 75%. 75% means 75 over 100. Of what number? That will be our x. That is our base, which goes on the bottom. Is 36 is our part and goes in the numerator. And now let's cross multiply. 75 times x is 75x, and we have 100 times 36. That gives us 75x equals 3,600. Dividing both sides by 75, we get x equals 3,600 divided by 75 is 48. So x is equal to 48. So we would say that 36 is 75% of 48. All right, number 5. How much interest will you earn by investing $1,200 at a simple interest rate of 2.5% per year for 6 years? All right, so let's use our little simple interest formula. I equals principal times rate times time. And again, we're going to substitute what we know. This time we're looking for the interest. So the I is our variable. Our principal is the $1,200 that we're investing. The interest rate is 2.5%. Written as a decimal would be 0.025. That's moving the decimal point over 2 places. All right, and then our time is 6 years. So all we have to do is multiply these three amounts together. 1,200 times 0.025 times 6 is 180. Interest is always in dollars, so this would be $180. All right, number 6. This is a vocabulary question. Complete. P% is equivalent to a fraction with a numerator of P and a denominator of, that would be 100. That's what percent means. And number 7, you deposited money in a savings account paying 4% simple interest per year. The first year you earned $75 in interest. How much interest will you earn during the following year? All right, well, on simple interest, and this is kind of a misleading question, they're assuming that the interest is paid to you. So that means that you start with the same amount of money, you're earning the same amount of interest every year. So if you earn $75 the first year, you will earn $75 the following year. If you put that $75 in the account, then your deposit is now $75 bigger and you will earn 4% more, or you'll earn 4% on that 75 the next year. So this is kind of not a very good question in some ways. All right, if you have any questions, please ask. We do have one more problem, and I'm not going to do it. It is very similar. It says, give an example of a percent problem where the part is greater than the base. And we did one. Let me find it. Number 2, because 60 is the part, and it's bigger than the base of 50. All right? So if you have any further questions or need further examples, please let me know. Thank you very much.